Okay, assalamu alaikum girls. Today inshallah we will start revising this lesson 4.6. It's about adding expressions. So the goal of this lesson, we need to add expressions identifying the like terms and unlike terms. We have to make sure that we're adding the like terms. We basically need to solve some word problems and try to see and explore some reasoning or analyzing errors in expressions. Let's see how it's gonna go. So let's start by exploring or identifying the like terms and unlike terms. So basically, girls, the difference between like terms and unlike terms is like terms should have the same variable term. So looking at this example, these two terms are like terms because both of them have x variable, the same x variable. But on the other hand, we have unlike terms. These two terms, they are basically unlike terms because one of them is x squared and the other one is x, regardless of the number coefficient associated with it. We only look for the variable part. Since the variable is not exactly the same, then we call it unlike terms. If they have the same exact variable, they are called like terms. As you can see here as well, it's x squared. The other one is also x squared with 4. This one, the coefficient of it is not written, but it's 1. It's a hidden coefficient. Always, if it's not written, it's a 1. But here in the other example, they are unlike terms because one of them have the variable x, one of them have the variable y. So they should have the same variable. Now, another thing about like terms is that if they don't have a variable, like any normal numbers, it's basically again like terms because both of them, they don't have a variable, so we consider them as like terms. But here, if you have two terms, one of them is a number without a variable and the other one is a variable, then still it's unlike term because again, this one has a variable and this one doesn't. So again, if they are like terms, they should have either the same exact variable or both of them, they don't have the variable. Okay. طيب, our goal is to basically add only like terms. Let's see how this is gonna work. So a direct example, let's start by a guided practice. A direct example can be given as following. Again, the goal of the lesson is to add expressions, not only terms. So this is called an expression. It's a bunch of terms inside a bracket, and this is another expression. We need to try to combine as many like terms between them as much as possible, okay? So let's see how this is gonna work. Let's read the steps that will help us in adding expressions, okay? Step number 1, we need to drop out the parentheses. These are the parentheses, we have to drop them out, okay? Let's see. So first step is to drop out the parentheses. We will rewrite the problem in a way that it's the same exact problem, but without the parentheses. So the first expression is gonna be 1.3x minus 6 without the parentheses. Then just write the addition as it is down here. Now the other expression, again, I'm gonna write it without the parentheses, okay? So it's gonna be 5.5x plus 2. I'm not changing anything, I'm just writing it as it is, but again without the parentheses. So since I wrote both expressions without the parentheses, I can move forward for the second step. Step number 2 is to identify the like terms. You can use any shape to identify them or distinguish the like terms. I'd like to draw circles, triangles, or rectangles around like terms. For example, 1.3x is a term that have another like term equivalent to it. The other like term is basically 5.5x. This is a like term for the previous one. So I'm gonna draw the exact same shape around them, a rectangle, with the plus, the sign of this term. Always, girls, the sign is written before the term. So this term, the sign of it is positive. Okay? And if there is no sign written before the term, it's positive, but a hidden positive. You have to write it. Don't forget to do that. Okay? So these two terms are like terms. Therefore, I drew a rectangle around them. Now, moving for another like terms, we have the negative 6. I will draw a triangle around it. Can you see? I took it with the negative sign because always the term, the sign of it is before it, as you can see. And 2, which is a positive term. Okay, I drew the same triangle because both of them are numbers without a variable, therefore they are like terms. Now the y, since it does not have any like term with it, I'm just going to draw another shape that is just for this term. And of course, I will take it with the sign. Y is negative. Now, next step is to combine the like terms. So I have 5.5x and 1.3x. Both of them are positive. To combine them, I'm just going to take them on the side and try to combine them. 1.3x is positive. So positive 1.3x. And the other term is positive 5.5x. Now, how am I gonna combine them? To combine the like terms, you have to use saddest rule. Saddest rule was basically, if you remember, same signs add, different signs subtract, and always put the sign of greater absolute value or a greater number without a sign. Let's see how this is gonna work. So in this case, we have positive 1.3 and positive 5.5. Since both of them are positive, then they are same signs. So I have to add them. So I need to add these two numbers, 1.3 and 5.5. I'm just gonna add them. 3 plus 5 is 8. Now put the decimal down. 1 plus 5 is 6. And write the variable down. Don't forget to write the variable down, okay? Now, the last step is to ask yourself, is it going to be a positive answer or a negative answer? Remember, you always put the sign of the greater number. In this case, the greater number is 5.5. So I will put a positive sign, but it doesn't matter because both of them are positive. So the answer of combining these two triangular like terms are basically positive 6.8x. Now moving to the other terms. We have negative 6 and positive 2. I'll keep on adding until I can't add or combine any terms anymore. Okay? Negative 6 and positive 2. I'm just going to write them down here. Negative 6, positive 2. Again, one of them is negative, one of them is positive. So let's go back to the rule. Same signs, are they same signs? No, positive and negative. They are different signs. Since they are different signs, then you have to subtract them. 6 minus the 2 is going to be 4. And put the sign of the greater number. The greater number is 6. So the sign of the final answer should be same as the 6, negative. So it's going to be negative 4. Just put it down. Since there is no variable, I did not put any variable next to the 4. I didn't put anything here, okay? Now, last step, since the negative y does not have anything else we don't have anything else to combine it with the negative y, then I'm just going to write it down in the answer. Now, looking at my final expression, I cannot add anything anymore. All the terms are different or unlike terms. Therefore, I'm done with I'm done working on adding these expressions. So that's it. This is just the simple idea. Let's take another example. Okay. So here we have three expressions. We need to try to add the like terms in these expressions. Starting with the first one. First step is basically what? Drop out the parentheses. I'm just gonna write all expressions without the parentheses. Starting with the first one. 5x minus 2 over 3y. Okay? Then just don't write the parentheses. I didn't write them. Put the positive as it is. Moving to the second expression. 1 and 1 over 3y minus 3x. Again, I did not put the parentheses. Just now drag down the positive. Don't forget the positive, girls. It really matters if you forget it. Now write the final expression. We have 2x minus 1 over 3y. Okay. Now let's try to identify the like terms. Starting with the first one, we have 5x. Of course, there's a hidden positive. I'm not gonna forget to make sure that every term I'm highlighting, I know what's the sign of it. Always the sign is before the term, okay? Since there is no sign next to the 5 or before the term, I know if there is no sign, then it's a positive term. Okay, so we have positive 5x is a like term with what? With the negative 3x. Can you see? I took the negative with it. With what as well? With the 2x but positive, okay? So all of these are like terms. Yes, it can be three terms that are like terms and I can combine all of the three. It's okay. Now let's select the other like terms. We have negative 2 over 3y. We have positive 1 and 1 over 3y. And we have negative 1 over 3y. So since now I identified all the like terms, I can work on adding or combining them separately. So let's start with the terms that contains x. I will list them up here and try to combine them. Remember, to combine like terms, I need to use SADS. Same signs, add, different signs, subtract, and make sure to put the sign of greater number in the answer. Okay, so I will list down my x terms. I have positive 5x. I have negative 3x. And I have positive 2x. Now, what should I do? Try to combine them each two together, and then the answer of the first two, combine it with the third one, okay? So I'll just take the negative 2x, positive 2x, just add it after I finish these, okay? So I'm just gonna add it afterwards, okay? Just to make sure that I will add correctly. طيب, looking at these, I will start adding the first two terms. Positive 5x and negative 3x. Since they have different signs, I need to subtract them. 5 minus 3 is 2. Of course, x in my answer. It's gonna be positive because the 5 is greater than the 3, and I will take the same sign as the greater number, okay? Now I have positive 2x and positive 2x. Don't forget that I still have a third term that I need to add. It's a positive 2x, okay? Let's add them. I have, both of them are same signs, and then I need to add them. 2 plus 2 is 4. Of course, I'm gonna put the sign, both of them are the same number, basically, so I can put a positive sign, x. Why did I put a positive sign? Because both of them are positive, it doesn't matter, okay? So my final answer is what? After adding all three terms, 1, 2, 3, it's basically positive 4x. تمام. Now let's add the other three terms, the y terms. What are they? We have negative 2 over 3y, and I'll take the second one, positive 1 and 1 over 3y. Of course, the last one I need to also combine it with it, but later, okay? So I'll just write it down here, negative 1 and 1 over 3, sorry, y, negative 1 over 3y. طيب, starting with the first two terms, they have different signs, then I need to subtract them. But what I noticed that one of them is a fraction, one of them is improper. One of them is a mixed number. I cannot work with mixed number until I turn them into improper fractions. So 1 and 1 over 3 y, I need to rewrite it into an improper fraction. I don't want to see the one next to the fraction. I need to use the method where I have to multiply the whole number with the denominator. So 1 times 3 is 3. Then add it to the numerator. 3 plus 1 is going to be 4 over what? Over the same denominator 3. Of course, y. So I changed my mixed number 1 and 1 over 3 into an improper fraction 4 over 3. Why did I do that? Because again, I cannot work with mixed number as they are. I have to change them into improper fractions. So it's 4 over 3. Okay? Now I can work with my fraction normally. So since they are different signs, I have to subtract them. So I need to subtract 4 over 3 minus 2 over 3. How can I subtract fractions? We only subtract numerators. 4 minus 2 is 2 over the same denominator, 3 only. I don't subtract the denominators, only I write it down. What? Y. Now lastly, I have to define which sign I should follow, the 4 over 3 y or the 2 over 3 y. Of course, the 4 over 3 because it's more than the 2 over 3. So since it's a positive number, then my answer should be positive. Okay? Now, this is the answer of adding only the first two terms. I still have to add the last term, which is negative 1 over 3y. Again, one of them is positive, one of them is negative. Then I have to subtract them. So I have 2 over 3 and 1 over 3. I need to subtract them on the side. Minus 1 over 3. So again, just subtract the numerators only. 2 minus 1 is 1 over the same denominator 3. And write the y down. Lastly, which sign I should write, negative or positive? It should be a positive number because 2 over 3 is more than 1 over 3. So my final answer is positive 1 over 3y. And of course, I cannot combine these two terms, then I'm done. Okay, so again, this whole lesson is about organizing your answers, trying to have the best way of writing down your answers, and just make sure that when you are working with the numbers, work with the numbers on the side. Make sure to show your work, and make sure you always follow the correct rule of the correct way of combining like terms, which is using SADS. Okay, طيب. Now let's take a word problem. I just want to select some of the problems that are here. Okay, so let's take let's take this one. No, let's take this one. Okay. Joel spends $28 for an internet data service and pays $14.50 per month. Okay? And he spends $24.50 to join an online movie streaming site and pays 13.25 per month. Write an expression to represent the total cost of both memberships. Okay, let's start writing the expression of each membership. Okay, for the internet data, she spends $28 for an internet data service, and she pays 14.50 per month. So she pays 14.5 per month, means for each month. So remember, expression should have a variable, and my variable is the month, number of months. I don't know how many months, therefore it's a variable. And they said it in the question, months. This is a hint for me to use that as a variable. I wrote the expression of the first membership, the internet membership. Let's write the other membership, which is the movie streaming. So for the other membership, he spends $24.50 to join the online movie streaming. So $24.50, he doesn't spend it in every month, only to join it one time. Plus, and he pays $13.25 per month. Since the word per is mentioned, then I have to multiply it with number of months. So plus 13.25 multiplied by what? Which is number of months. Remember, in math, if the number is stick to the variable, between them there's a hidden multiplication. Okay, therefore I just stick the next to the number. Okay, so these are my two expressions. I need to write an expression to represent the total cost of both memberships. So basically I need to combine these two expressions. Okay, let's try to combine them in another slide. Okay, I'll just take an empty slide and try to combine them here. Okay, fine. So the first expression, which is the blue one, I'll just put a bracket or parentheses around it, and the second expression is this one. Okay, and I need to combine them. Remember, first step is to drop out the parentheses. So I will just make sure to drop it out and write the expressions without parentheses. Okay, so it's gonna be 28 plus 14.5 plus the other expression without a parentheses, 24.50 or 0.5 plus 13.25 Now second step is to identify the like terms. So I'll start with the number 28. This is a number. It does not have any variable. So I will look for another term that is also a number that does not have a variable with it. So make sure to write a positive next to it, because if there is no sign before it, then it's a positive sign. Okay, this is my first term. What is the another term that is like to it? We have 24.5, also another term without a variable. Then they are like terms, and there is no more other terms, okay, that are like to them. So we also have positive 14.5 This is a term, okay, with the variable m. It's a positive term. What else? We have another term that is like to it, is basically 13.25 Since it's the same variable, then I'm just gonna circle it as well. Okay, use the same shape. Therefore, I know that the red ones are like terms and the green ones are like terms. Let's start combining the first two terms, 28 and 24.5. Okay, so I'll just take them on the side. Positive 28 and what? Positive 24.5. Positive 24.5. make sure you line up the number correctly. I lined up the ones with the ones, the tens with the tens, and the decimal in this number, 0.5, is written on the side, does not actually have a corresponding decimal here, but I know the 28 is basically 28 point what? 0.0. There is no decimal, then I just add 0.0. Why do I do that? Because it's always better to, whenever you are adding decimals, it's always better to rewrite them in a way that both of them will look like a decimal. So I rewrote the 28 into a decimal form, okay? Too many arrows. Just try to erase them. Okay. Now looking at these two numbers, I want to combine these two like terms. Both of them are positive, then I have to add them using سادس rule. Same sign, add. Okay? Yalla, starting from the right, the addition, okay? 0 plus 5 is 5. Put the decimal down. 8 plus 4 is 12. 2 is down, 1 is regrouped up. Now, 1 plus 2 plus 2 is basically 5. The answer should be positive because the 28 is more than the other number. So I'll take the same sign of it, but basically it doesn't matter. So it's basically positive 52.5. Okay? Now, moving to the other example, the other terms. Okay? 14.5 m and 13.25 m. Both of them are positive. Everything is positive. 14.5 m and the other one is what? 13.25 m. This is a positive, by the way. 13.25. Can you see I lined up the decimals on top of each other? The ones together, the tens are together, and the tenths are together. But I have here a 5, so the corresponding hundredths to it is 0 because I don't have a number here. Of course, m, and it's a positive number. Since both are positive, I need to add them. Based on what? Based on Sadis rule. Same signs, add. Sorry. So now I have to combine them. 0 plus 5 is 5. 5 plus 2 is 7. Put the decimal down. 4 plus 3 is 7. 1 plus 1 is also 2. Now since the 14.50 is greater, then I'll just put the same sign of it. Of course, don't forget the variable m. Never leave the variable out. So plus 27.75 m. Since I cannot combine them, then this is my final answer. So she basically spent 52.5 plus 27.75 per month. Okay, this is what she spends. Okay, try to explore these questions here. Try to solve them. Of course, don't forget to use Sadis rule. I'll take a reasoning question. Let's do this one. Question number 14. On a math test, Sarah has to identify all the coefficients and constants of the expression 4 plus n plus 7m. Sarah identifies only the coefficients. Remember, girls, the coefficient is basically, let's recall what does coefficient and constant means. So if I have this expression, plus 7, let's say. The constant is the number that does not have a variable and standing by itself. It's a normal number without a variable. In this case, it's the 7. It doesn't have any variable, then we call it a constant. And this constant have a positive sign, okay? Now, the coefficient is basically the number that is stick to a variable. In this case, the 3. Since the 3 is associated with a variable x, then the 3 we call it a coefficient of the x. Coefficient of the x, and the sign of the 3 is, since it's not written, then it's positive, okay? And the x is basically a variable. This is the very variable. This is the very basic thing we learned when we started learning expressions. So Sarah identifies the only coefficients as 7, and the only constant is 4. Do you agree or not? Let's see. So the expression is what? 4 plus n plus 7m. Now we agree totally that the 4 is the only constant, since it's the only number that is not associated with any variable. So yes, in this part she is correct. It's a constant and we don't have any other constant. That's correct. Now looking at the coefficient, what are the coefficients? To find the coefficient goes, you have to look at each variable and ask yourself, what's the number before it? The n variable, the number before it is 7. Then this 7 is the coefficient of m. Okay? But looking at the variable n, there is no coefficient written, but I know for sure there's a hidden 1. Remember? If there is no number written, then it's a 1 for sure. So the coefficient of number n is 1. It's not written, but it's there. It is a coefficient. So 7 is not the only coefficient. We have another one that is hidden. It's number 1. It's also a coefficient because it's associated with the variable n. It's not written because usually if the coefficient is 1, we don't write it. Okay? So identify all coefficients. We have 7 with the m. It's the coefficient with m. And 1, it's a coefficient with n. Okay? Identify all the constant. 4 is the only constant. What error did Sarah likely make? Of course, the common error that can be made here is that she forgot that there's a hidden coefficient next to the n. It's number 1. In this case, you have to make sure that this information is always acknowledged, and you know that definitely there's a number hidden next to a variable. If there is no number written, then the number that is hidden, then it's number 1, okay? That's it. طيب. That's it for this lesson. Try to solve more examples about this lesson. Check out the examples in the book. Try to solve and check your answer from the book answer key, yes. Okay.